Alright, as we saw in class, we are now talking about integration, which is basically finding the area underneath the curve to the x-axis. We start off with rectangles, seeing how many rectangles we can fit under the curve, and that will give us an approximate area. Now we're going to do basically the same idea, just with a different geometric shape. We're going to be working with the trapezoid. So let's start off with our first question. I want to find the area under the curve between 0 and 2 pi for the equation of sine x. So I think it always helps to draw a picture before you start. And I'm going to keep it easy on ourselves. I'm just going to do 4 trapezoids. I think we'll get a nice picture with that. So, first thing we need to do is we need to draw our 4 trapezoids. So we have an interval from 0 to 2 pi. So we have and we want 4 trapezoids. So that means our interval has to be pi over 2. And yes, I did plan that because that works out nicely for the sine function. So here we're going to have our first interval from 0 to pi over 2. So we start our first, our first base of the trapezoid is right there. And our second base is going to be right here. Here's the height of our trapezoid. And then the diagonal side of the trapezoid. Not true, this does look like a triangle, but basically it's the same area formula. Just except one of those bases is going to be equal to 0. Here is our second base, or second trapezoid, from pi over 2 to pi. And again, looks like another triangle. Here's our third trapezoid from pi to 3 pi over 2. There's our height. There's one base. There's the second base. And last but not least, we have our fourth height. One base. And then the other base. Okay, so I want to find the area of each one of those trapezoids, and we're going to add them up to each other. So we have area is going to be approximate because we have all this extra space left everywhere. So we have extra space here, some here, some here. So it's going to be not too accurate, but still it's just an approximation. So it is approximately, the area equation for a trapezoid is base 1 plus base 2 divided by 2 times the height. So our first base is going to be f of 0 plus our second base divided by 2 times our delta x, which in this case is pi over 2, so I'm just going to write that in now. Plus the area of our second triangle, or trapezoid I should say, is f of pi over 2 plus f of pi divided by 2 times our delta x plus our third trapezoid divided by 2 times our delta x. And then last but not least, our fourth trapezoid. I'm just going to go down here to save space. We have f of 3 pi over 2 plus f of 2 pi divided by 2 times our delta x. Now I'm going to try and get myself some more real estate here, so just be a little patient. So we know our area equation is going to be approximately, it seems like we're always multiplying by pi over 2 and divided by 2. So what I'm going to do is I'm going to factor it out. So as you can see here, there's a divided by 2, and there's always a pi over 2 in each one. So we can factor out of that, out of every term. So if we're dividing by 2, it's the same thing as multiplying by 1/2. And every term has a pi over 2. So that's going to make it look a little nicer. So we have f of 0 plus f of pi over 2 plus another f of pi over 2. Okay, so that's 2 f pi over 2s plus f of pi plus another f of pi, so that's 2 f of pi's plus f 3 pi over 2, plus, okay, 2f 3 pi over 2, and then just 1 2 pi. Okay, now let's evaluate each one. F of 0, sine of 0 is going to equal 0. F of pi over 2, sine of pi over 2 is going to be 1. Then so this is going to equal to 2. F of pi is going to equal 0, so 2 times 0 is 0. This is going to equal -1. And this is going to equal 0. Okay. Interesting. So that means we have, inside the parentheses, we have 0 plus 2 plus 1 plus -1 plus 0, which is just 1. Okay, so the area under the curve of sine of x from 0 to 2 pi is equal to pi over 4. Alright, so that was the example of trapezoid rule. So I want to give the formal definition for the trapezoid rule. If we're trying to integrate from a to b of some function f of x, and when we use the trapezoid rule, it boils down to this. Now you saw last time we factored out the change in the x, and we also factored out the divided by 2. Okay, so that's what we're going to do here. And you also notice that the first and last terms were the only ones that were alone. That everything else had 2. Okay. So we have delta x divided by 2 times all these function values, and n, this n here, so depending on how many trapezoids you want to use. Okay, so these x values, these x1, x2, x3, those are going to be the bases of your trapezoid. You're going to plug them into the function, and you're going to evaluate and estimate the area as is. Alright, one more application problem. So to use the trapezoid rule to estimate the area under the curve, use 8 subintervals. So 8 subintervals, it means for delta x is going to be 0.5, or 1/2, I mean. This time I'm not even going to use a graph. I'm just going to use a chart to organize my work. So we're going to start, we're going from 1 to 5 with subintervals of 1/2. So our first number is going to be 1, next is 1.5, and so on. Now I'm going to evaluate each one of these functions, each one of these x values inside the function of square root of 1 plus x squared. So these numbers came from just plugging these numbers into this equation, and then simplifying as far as you can. I just left inside the square root. No reason to make it difficult on yourself for now. Now we're going to plug into the trapezoid rule. So we know the trapezoid rule says that the integral 1 to 5 of, okay, so the integral is talking about the area, so that is approximately delta x divided by 2, so 1/2 divided by another 2, times our first function value, which is square root of 2, plus 2 times our second function value plus 2 times our third one plus 2 times all the rest of these guys except just one of the last term. Okay, so we have one of the first term, all of the middle terms, and just one of the last term. Now we're going to add all those together, multiply by 1/2 times divided by 2 is 1/4, and we're going to get our approximate area. And after just hours and hours of plugging it into the calculator to make sure it's right, we get approximately 12.76. And that's the total area under the curve of square root of 1 plus x squared from 1 to 5. Okay, that's it for this video. We're going to do some more practice problems with this in class, and as well continue with the Riemann sums with rectangles. And hopefully soon we'll be able to find patterns so we can do this much quicker and much more efficient.